Birds build houses, monkeys make tools, and ants grow agriculture. You could argue that what separates us from other animals is that we have harnessed energy, starting many thousands of years ago with fire. Burning biomass, like wood, straw, or animal dung, allowed humans to walk off the savanna, through the Ice Age, and into the modern era. Our relationship with fire is so important that many scientists believe humans could not have evolved without it. Even today, 1/10 of global energy comes from burning biomass. For 2.8 billion people, that's almost 40% of global population, biomass still provides heat and cooking. Without it, they could freeze or starve. Biomass essentially provides them life. But it also produces huge volumes of CO2. Wood is one of the few energy sources that emits more carbon than coal, and it can be deadly. Inhaling the smoke of a wood fire in a closed hut for an hour is the equivalent of smoking 400 cigarettes. Ugh. This makes biomass our most deadly energy source, killing 2 million people per year. Another example of a challenging energy trade-off. The rural poor of Latin America, Africa, India, and Asia need stoves that burn biomass more cleanly and efficiently, and they need cleaner cooking fuels. The gradual development of these regions are helping them get there, but it will take time. There are other, cleaner ways to use biomass. In many parts of the world, crop waste is burned to generate power. If the crops are replanted, then the CO2 emissions are offset by the new crop, making it carbon neutral. This works especially well if the crop or lumber waste can power industrial processes right where it's grown, like in Brazil's cane fields. These processes burn far less biomass than heating and cooking in the developing world, but they're growing. And as other energy sources become more expensive, we'll see more creative and cleaner ways of using our oldest energy source. There are two main kinds of biofuels. Alcohols, mostly ethanol, the same alcohol found in beer, wine, and even liquor. In fact, it's made in the very same way, by fermenting sugar. Then there's biodiesel, made from a fairly simple conversion of plant oils, like corn, soybean, and even grapeseed. Today, biofuels come from the same agricultural system used to grow food. Biofuels can be used in our existing cars and planes. They're mostly carbon neutral, since their CO2 emissions may be absorbed by new plants, and they can be grown domestically, reducing energy imports. But their biggest challenge is low energy density. In fact, to make a gallon of corn ethanol takes 64 ears of field corn. That's usually more than 50 plants, plus the natural gas and diesel fuel required to fertilize, harvest, and process it. Most studies have shown that corn ethanol doesn't provide any more energy than it took to make it. There are crops that do a bit better, like sugarcane, but to improve biofuels in the future, like in many energies, will require better efficiency, getting more liquid fuel per acre. There are two ways proposed to do that: growing special algae that produces a lot of oil for biodiesel, and growing specialized energy crops that aren't food, which produce huge amounts of cellulose, the woody structure of plants. Then using a high-tech enzyme process to break down that entire crop into sugars that can be fermented. This could double or even triple yields per acre. These and other new technologies that turn food and lumber waste into fuel are not quite commercial and still very expensive, but they may one day make biofuels cheaper than gasoline. Yet there is still the challenge of energy density, just the sheer volume of plant material, arable land, and water required.